Okay, this is what we did in class on Tuesday and Wednesday. If you missed class and need to get the notes, you should follow along in your book. We're on page 25. And first, we took a look at these two definitions right here. And what we noticed was, even though we know what this word is, this definition is very hard to understand. We don't understand some of these terms here, and this definition doesn't make a lot of sense because the words in the definition are very hard. This word here, which is gauge, which is a word that probably we haven't heard about, when we read this definition, we know exactly what it means because these words are all very simple and very easy to understand, so we can understand this one. What we see from this is that when we write a definition for something, we need to use very simple, easy to understand terms so that we can understand the new word. In geometry, we start off with what's called the undefined terms, and it's right here, and these are our three undefined terms: point, line, and plane. We've already talked about them, and we already know what they are, and they're basically the simplest possible terms we could start with. Everything else we're going to use, we use these in the definition. For instance, a ray is a portion of a line that starts with a point and then goes in one direction. Collinear points are points that lie on the same line. You should have also taken this, which is posted on Google Classroom, and copied all these down into your notebooks. Notice here's undefined terms, point, line, and plane. That is on your test. There's also a question on your homework about this. Here's collinear and here's coplanar. Then we turned the page and we talked about this at the top, these two terms right here, complementary and supplementary. We've already talked about those previously in class, but we did include the definitions here. If you didn't write them in your notebook the last time, you should make sure you do have these written down. You will need them in the rest of this chapter. If you keep turning, we went on to page 29, which is where we got to the heart of this section that we're going to be doing. And we talk about conditional statements. Conditional statements are really easy. They're just anything written in the if-then form. The one I like to use that makes a lot of sense is, if it is Monday, then you go to school. We use if-then all the time. This is just one example of it. Then it tells us here that the hypothesis, that's the if clause. That's the first part. So this is the hypothesis right here, if it is Monday. And then the conclusion is the then part, so that's then you go to school. So those are the other definitions that we wrote down here: hypothesis, conclusion, and conditional statement, and the if-then statement. We looked at this one here, and we can use it with mathematical algebraic terms. If we have this algebra problem, then we know x is -3. In the whole world of algebra, is x always -3? No, but if we know this part here, then x is -3. The hypothesis is the first part, the conclusion is the second part. We can do it for this problem here. What's the hypothesis? Well, the hypothesis is the if x plus 7 equals 10, that's the hypothesis, and the conclusion is then x equals 3. That's the conclusion. Then we looked at the bottom of the page here at these other ones that are not math ones. The first two are not math ones. I'll go if you go. And they want us to write it in an if-then form. Well, the first one, sometimes we have to rearrange it. The most important thing is that when we rewrite these, that we write them so that they have the exact same meaning as what we had here. We need an if part, and we need a then part. So this one, I'll go if you go, well, it's if you go, then I'll go. Sometimes we have to switch the order of it to keep the same meaning. The next one here says there is smoke only if there is fire. Well, again, we're going to have to switch it. That is, if there's fire, then there is smoke. And finally, this bottom one. We have to think about what implies means. And implies, if you think about what that word means in other context, implies means that we're not directly saying it, but we're giving you a very good hint that this is going to be true. So this one becomes our if, and this becomes our then. If x equals 4, then x squared equals 16. And turn the page. Now counterexamples are at the top of the next page. And every year that I teach this, students start off thinking that counterexamples are really hard, but teenagers are actually the absolute best at counterexamples. Let's go back to the first one I said there. Let me get my book in the right place. Counterexample. I started off with this. If it is Monday, then you go to school. Can you find times that that's not true? Well, maybe you're sick. Or it's a holiday. Or it's summer. Or some other reason. In each of these cases, you're giving me an example of when it was a Monday, but you didn't have to go to school. Those are counterexamples. And that's exactly what our definition says. It's places where we're giving an example that's true for the first part, but shows that the second part is not true. That's all that a counterexample is. So we did this example here in class together. If two numbers are odd, then their sum is odd. And we said first, what's the hypothesis? Well, that's the first part. If two numbers are odd, and then identify the conclusion, then their sum is odd. That's the conclusion. Now we want to give a counterexample. We want to give a time when we can find two numbers that are odd, and their sum is not odd. Well, that's any odd numbers, 1 and 3. They're odd, but their sum is 4. That's all there is with counterexamples. Then we did a few more examples that are not in our book. And ones like these may or may not be on your test, so you might want to pay attention to these. First we want to write as a conditional statement. Then we're going to, what is the hypothesis and what is the conclusion? An angle with 80 degrees is acute. Well, if an angle has 80 degrees, then it is acute. Each time the beginning part is the hypotenuse, the hypothesis, and the second part is the conclusion. Okay, I paused the recording so that I could write these out and you didn't have to wait for me to write everything. 2 points on the same line are collinear. We could write that as a conditional statement by if 2 points are on the same line, then they are collinear. The beginning part is the hypothesis. The second part is the conclusion. 2 parallel lines do not touch. If 2 lines are parallel, that's the hypothesis. Then they do not touch is the conclusion. And finally, if 2 lines are parallel, like this, then they are coplanar. That's the conclusion. That's the hypothesis. Okay, now we're going to look at a couple more examples here. On these, we're going to tell if each statement is true or false, and you have a bunch of questions on your test where to ask if things are true or false. Then if it's false, we're going to give a counterexample that shows that it's false. If it's an acute angle, if an angle is acute, then it is 75 degrees. Well, it could be, but it might not be, because what if the angle is 60 degrees? That's an acute angle that's not 75. Another example would be 30 degrees, or 2 degrees. Anything that is acute but not 75 is a counterexample. The next one, if 2 angles have the same vertex, then they are adjacent. Well, I could draw it like this, the vertex of the angle is this point right here. This would show one where the two angles have the same vertex and they are adjacent. But for a counterexample, I could show it like this. This angle here, number 1 and number 2, they have the same vertex, but they're not adjacent. So that's a counterexample. If a number is divisible by 2, so this seemed to be confusing some people. When it says it's divisible by 2, it means a number that I can take and say like 6 divided by 2 is 3. And it gives me a whole number answer. That's what divisible by 2 means. Or 8 divided by 2 equals 4. Those are divisible by 2. So this is saying if the number is divisible by 2, then the original number is even. 6 divided by 2 is 3. 8 divided by 2 is 4. Each of these numbers here that I can divide by 2 is even, so this one's always true. Number 4, if a geometric figure has an endpoint, then it's a line segment. Well, that one's false. What other kind of shape has an endpoint? Well, that would be a ray. And finally, if it's divisible by 2, then it's also divisible by 4. Well, that's false, because while it's true that 8 is divisible by 2, and 8 is divisible by 4, that one's okay. But what if we picked a number like 6? 6 is divisible by 2, but it's not divisible by 4. It's not a whole number if I divide it by 4. So this is a counterexample to this one.